All right. This is a pretty fun one. This is from the Central American and Caribbean Math Olympiad. This is from 2017, problem 4. Very cool and relatively simple um geometry problem um on cyclic quadrilaterals a lot. And yeah, it's it reads ABC is a right angle triangle with angle ABC equal to 90 degrees. B prime is a reflection of B over AC. M is the midpoint of AC. We choose D on the ray BM such that BD is equal to AC. And then we prove that B prime C is the angle bisector of angle MB prime D. And something to note is that AB is less than BC, else this does lead to some issues. So this is a very important note. Um, Props to the person who uploaded this in Art of Problem Solving website. She'll link the problem below. Um, but yeah, let's draw this piece by piece. So firstly, ABC is a right angle triangle, and very important thing, AB is less than BC. So let's draw that angle. I mean, yeah, we can draw it nicer. That's it. Yeah. Okay. So triangle ABC. So let's make that a little bit right. Okay. Yeah. Triangle ABC. Let's label the points A, B, and C. And this is 90 degrees. B prime is a reflection of B over AC. So that means we're basically gonna flip this um, with respect to AC. So B should lie somewhere approximately over here. Not gonna be very exact. Um, Actually, I just realized we can simply just grab um, this triangle and flip it if that's possible. This would become a kite. So no, it's not a triangle. No. Okay. Um. So we'll draw this. Um. And this would be B prime. And then this would be BC. So not exact, but it's basically as close as we'll get here. And this is also 90 degrees. Um. Since it's a reflection, angle A B prime C will just be equal to A B C. Angle ABC. And then M is the midpoint of AC. So we have that M. M is the midpoint of AC. Then we choose D on the ray BM such that BD is equal to AC. So something like that. Kind of. We can do better. Yeah, I say something like that. That works. And yes, yeah, so BD is equal to AC, which works. And then we need to prove. I just realized that it's BM and not B prime M. I had that exact same issue when initially solving the problem, and the exact same thing happened to me once again. I'm sorry. But yeah, um, this is point D approximately. And then now we gotta prove that B prime C is the angle bisector of angle M, B prime D. So let's make that small line here. the angle. And so we gotta prove that, hold on, let me make this drawing a little bit better. Yeah, let's kind of change the color to kind of separate the drawing itself from the additional annotation. So this is a basic drawing in it of itself. I'm going to prove that this angle is similar to or equal to this angle. So first things first, what we can note is that quadrilateral B prime is a right kite, right? So this would imply that it is cyclic because ABC is supplementary to angle AB prime C. So these 4 points, ABC and B prime, they all lie on a circle. This is a very ugly circle. Hold on. And you might notice that, I mean, in this drawing, you can already see that D might perchance also lie in the circumcircle. But we gotta prove that. But that's kind of proved already. Because we can prove this pretty easily. We see that AC must be the circumference, I mean, not circumference, the diameter of the circle, because angle ABC is a right angle, and it's an inscribed right angle. So by definition, it must open on the diameter, and so the diameter must be AC. And something else that we can note is that since AC is a diameter and M is the midpoint of AC, then AM and MC are both going to be equal to the radius of the circle. So there's that, and additionally, since M is the center of the circle, then BM and B prime M are also gonna be equal. So we have these 4 segments that are automatically gonna be equal in length to each other. Anyway, it's back to proving that D is on the circle. So now we know that AC is the diameter, right? And BD is a line that passes through M and is equal to AC. So we know that AC, the length of AC, is going to be the diameter of the circle. So BD is equal to the diameter of the circle. And it passes through M, which is the center of the circle. So this implies that D must be diametrically opposite to B, since BD is equal to the diameter of the circle and it passes through the center of the circle. So now we know that D also lies on the circumcircle. So we have that D must lie on the circumcircle, and we can, you know, kind of show that, but it's the entire line, not just this part, but the whole segment. Just keep that in mind. And so now we have that. Now from here on out, we can kind of angle chase the whole thing actually. So let's set angle ABM as X and angle MBC is Y. Then we know that since, you know, B prime is reflected across AC with respect to B, or yeah, it's B prime is a reflection of B across AC. We know that AB is going to be equal to AB prime, and CB is also going to be equal to CB prime. Since it's a reflection, these segments are going to maintain the same length because it's a reflection. So again, I mean, we already proved this because by saying that it was a kite, But this further, reinforces that proof that might have been a little bit incomplete at the beginning of the video. But yeah, since it's a reflection, AB is going to be equal to AB prime, and B prime C is going to be equal to BC. So yeah, triangle ABC is going to be similar to triangle AB prime C. In fact, congruent by the side-side theorem, or the side angle side theorem as well, whichever you prefer, since ABC is equal to AB prime C. So another thing is that you can note that triangle AMB is isosceles with base AB. So angle BAM is going to be equal to x as well. And similarly, angle MCB is also going to be equal to y, since triangle BMC is isosceles with base BC. And then from here on out, we know that since AB prime C, the triangle, is congruent to triangle ABC, we can, just write these angles again on this other triangle. And now we have one angle, M, angle MB prime C, which should be equal to CB prime D. But we gotta prove that. And how exactly would we prove that? Well, we know that x and y are equal to 90, since, angle ABC is equal to 90. So x plus y is going to be equal to 90. So we have that. Let's write that down. We also know that quadrilateral ABDB prime, like this quadrilateral, this is cyclic, right? Since all these points lie on the same circle that we previously stated. So since x plus y is equal to 90, and this is cyclic, by definition, angle ABD must be supplementary to angle AB prime D. So now we know that angle ABD plus angle DB prime A is going to be equal to 180, and then we can do substitution here, right? So angle ABD would be x, and then angle DB prime A would be x plus y plus the remaining angle that we need to check to prove that's equal to y. We have angle CB prime D, and this is equal to 180, but we know that angles x plus angle y is going to be equal to 90 degrees. So if we just multiply this by 2, we're going to know that, that's right. I'm looking for space to write. Let's just draw a really ugly arrow over here. Then 2x plus y is going to be equal to 2 times 90, which is just 180. So we can write 180 in terms of x and y, which would just be 2x plus 2y. And then we can isolate for angle CB prime D. And this is going to be 2x, so these two cancel out this one. And y, you subtract it on both sides, which leaves angle CB prime D being equal to y. So this is y, and this means that angle MB prime C is equal to angle CB prime D, and this would imply that the line B prime C, it bisects the angle MB prime D, because then angle MB prime D would be 2y. So yeah, that's basically it. We've proven what we needed to prove. So this geometry problem, I didn't really write like a formal proof or anything because I thought it would be a lot nicer to demonstrate. But if you personally felt like you would have rather had like a proof written in this video, then please, I would really appreciate the feedback. So if you could comment that or let me know, I would really appreciate this because, you know, I'm just, I'm, I'm barely starting out with these kinds of videos. So I would really appreciate, you know, some feedback, comments, and yeah, that's pretty much it. If you also have like another alternate solution or something, I would really like to know what it would be. So again, just comment down your thoughts. And yeah, I hope you enjoyed and I hope you understood everything that I laid down here. And that's about it. Bye bye.